Good afternoon, everyone. Welcome to this revision lesson number 4. We hope that you enjoy today's lesson. Let's see what we have today. Today we'll be revising structures, forces, loads, and properties of materials. We'll look at gears, pulleys, and other control mechanisms. We'll also look at the questions that may be used in, we'll be looking at structures. It is structures that we'll be looking at. We did gears, pulleys, and other control mechanisms yesterday. Static and dynamic forces. Now we want to look at the forces that act on structures. Now we are going to classify today's forces as static and dynamic forces. But before we do that, can you remember the other forces that we have done so far? We have done types of forces. Can you remember those forces that you have done in the other lessons that you had on structures? Shearing force, shearing, Kinkade. You have shearing, you have compression, you have tension. Torsion. Torsion is the twisting force. It is called torsion. Yes. Shearing. Okay. Now, we will also classify forces as static or dynamic. Let us look at this example. There is a person sitting on a structure, namely a chair. As long as a person sits still on a chair, the force on the chair remains in the same place. This is called stationary or static force. Okay, let us look at dynamic forces. When a moving object exerts a force on another object, you can say that the force is dynamic. Like these vehicles, they are exerting a force on this bridge. On the beam of this bridge. Now, this force is dynamic because it is moving force. It is not like this kind of force in which a person is sitting still on a chair. This is static force because it is stationary. When we say something is stationary, it means it's not moving. But in this case, because the vehicles are moving on the bridge, we say this is dynamic force. So that's the difference. There are other forces also that are acting on this bridge. You have your compression, because the weight of these vehicles is exerting a compression force on the beam of this bridge. So the beam has to be very strong to withstand the compression. of the force, even though this force is also dynamic. It is a dynamic kind of force because it is exerted by moving objects. Okay, now that you understand the difference between static and dynamic force, in each of the following cases, state whether the force exerted on the table is static or dynamic. Explain why you say so in each case. Okay, the surface is the table. Now, A pot of flowers standing on the table. Is that static or dynamic force? Tando, you're correct. It is static force because the pot of flowers is standing still. A cat walking on the table. Please tell me, what force is it? Is it static or dynamic and why? I want to see if you understand these forces. A cat walking on the table. What force is that? It's dynamic. Why are we saying it's dynamic? Because a moving object is exerting force. A boy rolling a soccer ball over the table. Is that static or dynamic force? A boy rolling a soccer ball over the table. It's dynamic. See, it's dynamic. Why? Because it's a moving object. A man scrubbing the table. Is it static or dynamic force? D. Is it static or dynamic force? A man scrubbing the table. D. D. The answer for D. D is dynamic because the hand is moving. When you are scrubbing, your hand is moving. Now, I hope you understand the difference between static and dynamic forces. Okay, these are your answers. Now we go to loads. You have an even load and an uneven load. Look at these illustrations. A load that exerts an equal force over the whole structure that supports it is called an even load. A load that mainly exerts a force on one part of the structure that supports it is called an uneven load. This load, where you have stacked pots, is it an even or an uneven load? The first table with a stack of pots, is it an even or it is an uneven load? Why do you say so, Tando? Because the load is exerting force on one part of the structure. Okay, so this one becomes an even load. Why is it even? Because it is distributed. It exerts an equal force over the whole structure that supports it. Okay. And also looking at this truck, the truck on the top, what kind of a load do we see on this truck? Is it an even or an uneven load? On the truck, it is an. This, what kind of a load is this? Please raise your hands. I want to talk to you. What kind of a load is this? Thando Ngubane, unmute yourself and tell me what kind of a load is this?
It's an even load
Why?
because the force is, the thing is, those things.
The load
Yes, the load is like equal.
is distributed over the structure.
Yes.
The track at the bottom, Thando, that is an uneven load, okay?
Yes.
Because the load exerts a force over
One load.
one part of the structure. Okay, so now how can you define even and uneven load?
Like, okay, ma'am, even it's when like load is distributed evenly, and uneven it's when load is distributed unevenly, like it's not equal.
Okay, now remember to put in your definition force and the structure, because even load, it has a bearing on force and the structure.
Okay, ma'am.
Thank you very much, Thando. Thank you, Thando. Okay, so this is where you will be defining even and uneven load, and even the forces, static and dynamic force. If you are asked to define dynamic force, how will you define dynamic force? Raise your hands and tell me. What is dynamic force? Maybe there's a question that says, define the following terms. Dynamic force. How will you answer that? Thando?
Ma'am, I would say dynamic forces are moving forces.
Yes. When a moving object exerts force on a structure, we say that is dynamic force. You are right. Okay. Remember, when the teacher is marking, they are looking for some keywords. Okay, but you must use those words in a correct context.
Okay, ma'am.
Force? Dynamic force is a force that is exerted by a moving object on a structure.
Yes, ma'am.
Okay?
Yes, ma'am.
Okay. When a moving object exerts a force on another object, you can say the force is dynamic. Static force. Static force. How can you define static force to show that you understand it? How can you define static force? Anyone? What is static force? In your own words, explain what is force. Static force is the force that is exerted by a load that remains in the same place on a structure. Static force is force that is exerted by load that remains on the same place on the structure. That is static force. Or you can say it is force that is exerted by an object that is not moving. I will mark that one correct too. Okay. So those are your forces, the dynamic and the static forces, even and uneven load. Now, let us see the application of these forces. Think of a house. Think of a house with a zinc roof and the forces that the sheets exert on the roof structure. Okay? Is the load even or uneven? Zinc roofs or metal sheets, this metal sheet kind of corrugated iron. Yeah, that's what I wanted to say. Think of a house with corrugated iron and the forces that sheets, those corrugated iron sheets exert on the roof structure. Is the load even or uneven? Why do you say so? The load is even. And Amra, you are correct. The force is static because the roof tiles, those sheets, those corrugated iron sheets, they stay in one place. Okay, it's even load, static force. Okay. Then to think of people climbing up and down wooden steps. Is the load even or uneven? 2A, is the load even or uneven? People climbing up and down the stairs. It is even load. People climbing up and down the stairs. It is because people are not standing still on one spot. Okay, they are moving. People, it's not one person, it's different people. So there is a weight there, and it is moving. So the load is it is even, and it is also dynamic because the people are moving. People are climbing up and down the stairs. So the load is dynamic, it is not static. Okay. So there are your answers. With the roof tiles, the load is even because it is spread out all over the roof. B, the load is static because the sheets of zinc do not move around. With people climbing up and down the stairs, the load is uneven because the person is standing on one. Oh, the load is uneven because a person is standing. No, this answer is wrong because we said people are climbing up and down the stairs. So this one will be wrong. This is what I would mark wrong. The load is dynamic because the weight of the person is moving from one step to another. So this one, the load is even because the people, the weight of the people is distributed on the staircase. Right, now complete the table below. Sitting on a chair, rocking a chair. Okay, let us take it one by one. Sitting on a chair. If it was a worksheet, you would be ticking on it. Okay, sitting on a chair, is it static or dynamic force? I want you to speak through your mics if you can, okay? Sitting on a chair is static. Is it even or uneven? What kind of a load is it? Is it even or uneven? It is it even or uneven? It's not even, it is uneven. Okay, remember we said a load that is distributed over the structure, then it is even. But that the one that is concentrated on the same spot, then it is uneven. So the correct answer there is uneven. Rocking a chair, if you are rocking a chair, is it static or dynamic force? When you are rocking a chair, is it static or dynamic force? It is static because you are moving the chair. You are moving the chair. Okay. Is it even or uneven load? The load. Think about the load. You are sitting on a chair and you are rocking it. So it becomes dynamic. But the load, what kind of a load is it? The load is uneven because you're still sitting on the same spot of the structure. Okay, standing on a trampoline. When you're standing on a trampoline, standing on a trampoline, is it static or dynamic? Standing. It is static when you're standing on a trampoline. Correct, Kelly? Now, is it an even or an uneven load when you're standing on the trampoline? It is an uneven because you're standing on one spot. You're standing on one spot. Bouncing on a trampoline. Bouncing on a trampoline. It's dynamic. It's dynamic. Bouncing on a trampoline, it's dynamic because it's moving. Now, is it an even or an uneven load? Is it an even or an uneven load? It is an even load because you will be bouncing from one place to another. It is even load. Right, the brickwork above a lintel. The brickwork, is it static or dynamic force? The brickwork above a lintel, static or dynamic? It is static because the bricks are not moving. It is static, a static force. Is it an even or uneven load? The brickwork over a lintel. Is it an even or an uneven load? What kind of a load is it? What kind of a load is it? It is even, Mkabet. It is even because the bricks are not piled up one above another. They are evenly distributed over the lintel. So it is an even load. It is an even load. Okay. A car driving over a bridge, you can answer this one. You can all answer this one. A car driving over a bridge is a static or dynamic force? What force is it? It's dynamic force because the car is moving. Is it an even or an uneven load? A car, one car driving over a bridge. One car driving over a bridge. What kind of a load is it? It is an uneven load. It is an uneven load. If it was cars driving over a bridge, it would be even load because that would be a distribution of weight, of force over different parts of the structure that is a bridge. But if it's one car driving over a bridge, then that becomes an uneven load because the car exerts a force where it is at a particular time of that bridge, over that bridge. A bouncing ball, is it a static or dynamic? Bouncing ball. It is dynamic. Is it even or uneven? Is it even or uneven? It is uneven because it's a bouncing ball, one bouncing ball. So it will bounce on that spot at a time. It will bounce on that spot at a time. Foo Fighters, you give me two answers, so I must do multiple choice. Yeah. A bus, car, and taxi crossing a bridge. Now I like this one. A bus, car, and taxi crossing a bridge. Is it static or dynamic force? It's dynamic force, okay? Then the load, is it an even or an uneven load? It is even, Tando, you're right. It is even load because it is a distribution of force over the entire structure, different points of the structure, not a concentrated a force on one spot of the structure. Okay. A heavy and light person on a seesaw. A heavy and light person on a seesaw. Right, is it static or dynamic force? It's dynamic. It is uneven. Dynamic and uneven. Okay. A person walking up one side of seesaw. One person walking up one side of seesaw. Is it a static or dynamic force? And then it is a person walking up one side. It is a dynamic force, and it is uneven because it is one person. It is the load. It is one concentrated. Yeah, it's a little bit challenging, especially, we will upload them, Tando. We'll upload this lesson. Okay. Then we go to structural members and their uses. The structural members and their uses. Now, we did this yesterday, and I made an error yesterday. I want to rectify that error. When I was making an explanation on these structural members, I said this one, the H gather. I confused the H gather and the I gather. And when I looked closely at these gathers, I realized that I made a mistake. This one doesn't make the railway track, as I said yesterday, but it makes, this is the one that makes the I gather and the H gather are not the same. Some books can show you that the I gather and the H gather are the same, but actually they are not. So this is the I gather and this is the H gather. So let us look at these beams and columns again. The ice profile is often used as upright supports or columns. For example, in buildings, it resists compression very well. Okay, we did talk about that yesterday. We said it resists compression and tension. Okay, now it is used as a column. The difference is the structural position in that structure. If it is upright, it is called a column. If it is horizontal, it is called a beam. Then the I profile is the one that is being used for railway tracks. You see, they don't look the same. You might be tempted to say this is the I gather. Actually, this is the I gather, this is the H gather. So this one is used for railway tracks. So this broad base allows the beam to withstand tension, and it gives it more stability. Then you have the U profile. This one facing upward, it will be a U. It is light. It is lighter than the H profile. It's used to provide horizontal support, for example, in shelves. Okay, the chassis of a truck is normally made of U-beams. Okay, you must remember the uses, where we use this for, where we use this, what we use it for. And then this one is the angle one, the angle gather, or the angle profile. This profile is used as angle iron, even if it is made of metal. It has higher bending strength than flat strips. It is light and it is often used for cross bracing in pylons, towers, and other structures. It is used for cross bracing, this one. Okay. Then you have a tube, the tube, okay. The tube is the best profile for resisting torsion. Remember, we said torsion is the force that involves twisting. So this one resists twisting. It's not easy to twist. And they are arranged in their order of strength. Okay? Please remember this. Okay. Right. Now, we are looking at properties of materials. That's why we went back to the beams and columns. We are looking at their properties because it is their properties which will give us good reason where to use them when we are building structures. Okay, I want you to take a few minutes to do this. From the list of materials below, choose a material that is very hard, thermoplastic, has the highest thermal conductivity, has the lowest thermal conductivity, melts and emits black smoke when it burns, is used to plate steel as a means of corrosion prevention, a metal that does not rust, very light due to low density, an alloy, and an elastic. I want you to choose from these words, okay, these materials. And quickly answer them, answer the questions, and then after that, I will give you the answers to this. You choose a material and you find a property for it, a characteristic for it. I'm going to give you 3 minutes to do that. Are you finishing? I'm here. I'm looking at your answers. Foo Fighters, I'm right here. I'm looking at your answers. Yes, I haven't seen any number 7 yet. 1.7. Okay. Let's see. There are your answers. Very hard. Very hard. It's diamond, you're correct. A thermoplastic is PEHD. If you can look at the bottom of your plastic bottles, you will see these symbols. Okay, some plastics, they do show these symbols, PEHD. Has a high thermal conductivity, corrugated iron. Has the lowest thermal conductivity, wool. That's why we use wool to insulate. That's why you wear wool jerseys when it's cold, because they insulate. Okay, they don't conduct heat. Melts and emits black smoke when it burns, that is nylon. It's used to coat steel. It's used to coat steel as a means of corrosion prevention. You know, I could take rubber. Rubber melts and emits black smoke when it burns. That's nylon, it doesn't melt. But rubber does emit black smoke when it is burnt, just that it doesn't melt. It's used to coat steel as a means of corrosion prevention, and that is zinc. That's why you have zinc corrugated iron. Zinc metal sheets for roofing. A metal that does not rust is stainless steel. You're correct. Most of you got that one correct. Very light due to low density polystyrene. You got that one correct too. An alloy is bronze. Elastic, it is rubber. Okay. Right. We will continue with properties of materials in our lesson tomorrow. Properties of materials are very important because it makes us choose materials when we are making structures so that there is no structural failure. Unfortunately, our time is up now. We have to go. Goodbye.